Solving harder log exponent equations. Okay, so we can't write 10 and 7 using the same base, so we're going to log both sides. Now, using the rules, I'm going to move the exponent into the front. And then don't forget, when you move that, it will contain brackets because it's the whole exponent in front of that. Not just, if you didn't do brackets, then you're just putting the 5 in the front. So I'm going to distribute this. Okay, anything with an x, I'm going to put it on the same side. So I'm going to move this term, so minus x log 7. Now I'm trying to get x alone, so I'm going to GCF the x out. And then to get x alone, I'm going to divide. Okay, now I'm ready to go to my calculator, so I'm typing this into my calculator, and it will be important to put brackets on that division. Okay, I will show you on this, I might not on some of the rest of them. So 5 log 7 divided by bracket 3 log 10 minus log 7. So I had brackets on that bottom half and 1.961. That's our value for x. Okay, solving this, she found out that x could be 2 and 7. Identify which one of these values is acceptable and explain why. So remember that when you have logs, that this is always positive result. So 6 minus 2 as a result, and 3 minus 2, that's positive, that's positive. So 2 would work. If I had a result 6 minus 7 or 3 minus 7, ooh, that's negative, so 7 would not work. Okay, and that's the explanation why the result always has to be positive. Solving the following, so I'm going to collect those together with the rules. So log 3 split with addition means I'm going to put them together with multiplication. So I'm going to now take the log expression, base, result, exponent, and change it into exponential. So that's the base, the result, exponent. So 3 to the 1 equals that. Okay, so I'm going to just change that to a 3. I'm going to FOIL, and I get x squared minus 2 minus 4, so minus 6x plus 8. How do I solve anything quadratic looking with two different types of variables here? I zero it out. Okay, now I'm going to factor, or try to at least, see if it is factorable. 5 times 1 makes that. Negative, negative adds to that. So x equals 5, x equals 1. When I plug it in, what is my result? So 5 minus 4 is positive. 5 minus 2 is positive. So that's positive results. It works. 1 subtract 4, that's already a fail. So I will cross that off. Number 4. So we're going to collect. We could do this 2 ways here. I could move everything to one side, or I can just keep this and collect those two. So maybe I'll show you both ways here. So log x, so that was subtraction, so I'm going to put them together with division. And then log x, and then this can move up there. So now, since that's the same and that's the same, I'm going to conclude that this will equal that. So 9 equals y squared, therefore y equals plus or minus 3. And I cannot have negative 3 because that would cause that result to be negative. Okay, if you had happened to do this, I'll show you if you had moved everything to one side, then that's what it would look like. And now you can collect these 3 together with the rules. So 27 divide by 3, and then the y squared would have to be in the bottom of that with the subtraction. Now if you arrange this, it would be base x exponent 0 equals this result. This is 1. Then you can see if I cross multiply, I can switch that, and then you can see y squared is 9, same. Solve. Okay, so this is the base exponent result. So I'm going to rewrite it as a log. So log of the base, and then the result equals the exponent. Okay, and then we understand that the log e is the exact same thing as writing ln. So now all I have to conclude is that 7 is going to equal 5 minus x. So if I subtract 5, 2 equals negative x, divide negative 2 equals x. Okay, so I'm going to collect log 4, and I'm going to put stuff back together with the rules. So the 2 will go on the top of the x, and this will be a division because of the subtraction. Now I'm going to rearrange this in exponential, so base 4 exponent 1 equals result. So that's just a 4. So I'm going to times that. In other words, times both sides by x plus 3. So 4x plus 12 equals x squared. So how do I solve equations that look like this? Zero them out. So I moved all that over, and then I'm going to try to factor this with a 6 and a 2. That will work. So x equals 6, x equals negative 2. So if I plug 6 in, that results positive. 6 plus 3 is positive. That works. Negative 2. Ooh, if I plug it in, that's already a negative base or negative result, so that's not going to work. Okay, so 7 and 8, you can do these 2 ways. You can collect, just separate both sides, or you can move everything to one side. So we'll do this way first. So I'm going to go log 2 of x minus 1 gets squared, and then there's a division by x minus 5, and then this side is log 2 of the x plus 1. So now I'm going to forget that because that's the same on both sides. So x minus 1 squared over x minus 5 equals x plus 1. Okay, so now I'm going to times both sides by x minus 5, which would get rid of that. And I'm going to square that, and it's going to create a doubled multiplication, right? So now I'm going to FOIL both sides. X squared minus 2x plus 1, x squared minus 4x minus 5. So I'm going to minus x squared from both sides. Algebra, I'm just trying to collect, isolate, so I'm going to add 4x. I'm going to minus 1. So I get negative 3. And let's check that out. So negative 3 minus 1, ooh, that's not good. So now there's actually no solution that will work, because that was the only one we came up with. Okay, so the other option here was if we had moved everything So if you had moved everything to one side, you would have just brought that over. You would have collected it as one unit. So that's what it would look like. Then you would rearrange, so 2 to the 0 equals this result. And then this is 1. And then you can see how we're going to end up exactly the same as in the algebra there. Okay, so let's do this with two separate sides. So log 4 on this side is separated with add, so we multiply. Now, since that's a log 4 and that's log 4, we're dropping that. It's the same. So therefore, 3x plus 6 equals x. So I'm going to go subtract 3x, divide by negative 2, negative 3 equals x. If I plug it in, oh, that's a negative result, so there's no solution. And you can also do this by moving that over. So if you move it over, it looks like that with a 0 there. So now I can collect all three of these with x plus 2 times the 3 and a divide by x. And then you can go 4 to the 0 equals this. And then you can make that a 1. And then you're going to find out, you're going to get exactly to that spot. 3x plus 6 equals, timesing that would be 1, or 1x. Okay, solving this, so we need to log both sides because we're not going to write with the same base. Okay, so rules. This will go in the front. Multiplication will split. So log 3 plus then this would move to the front. Okay, so that's the rules. Now I'm going to need to distribute that because it's the whole exponent, so you have to have brackets on that. Now everything that has an x in it, I'm moving over together. So minus x log 5. Now I'm going to GCF an x out. And to get x alone, I'm going to divide. And I'm going to type that into my calculator. So be careful, you'll want brackets divided by brackets, right? When you're typing into your calculator, that's how you want it to look. And my final answer, once I've typed it into my calculator, negative 2.009. Number 10, so I'm going to collect, so log 4 of, put it back together, so x squared, subtract was the division. Now I'm going to rearrange the log form to exponential, so base, exponent, result. 4 to the 1 is just 4. Now I'm going to times both sides by x plus 3. And now I'm going to think, hey, that's a quadratic, zero it out, factor 6 times 2 makes the 12. So x equals 6, x equals negative 2. If I plug in the 6, that's good, that's good. If I plug in the negative 2, that is a negative result. Okay, Kim solved this. Explain why x equals 3 is an extraneous root. So this result, or if we plug in so if we plug into the result positions, this is a negative 1 result. This is also a negative 1 result. And the result has to be positive. So therefore that does not work. Okay, solve. So we can't do same base with a 5 and a 9. So we're going to log both sides. Now with the rules, multiplication, I'm going to split with an add. So log 6 plus, this will go into the front. This will go into the front. I'm going to distribute and that. So log 6. So 3x log 5 plus 2 log 5, 2 log 9 minus x log 9. Anything with x we're going to put to one side. So 3x log 5 keep, and then move, so plus x log 9. Anything that's not an x will go onto the other side, so 2 log 9. Then I will have to move and move. So minus log 6, moving it, and minus 2 log 5. On this side now I can take out an x. And to get x alone, I will divide. So this is what I will be typing into my calculator. And don't forget to make sure that you're putting brackets, all that stuff on the top, divided by brackets at the bottom. And I'm going to get x to equal negative 0.088. Okay, solving, so I'm going to group this together. So log 3, so 2 to the 4th, and then the subtract is a divide, 8 to the 1/3. So all this equals a, so I'm going to kind of say those are the same, so I can conclude I don't need them. So 2 to the 4th over 8, 1/3 equals a. So 2 to the 4th is 16. This is the same thing as the cubed root of 8, which is 2. So therefore a equals 8. Okay, I'm going to group that together. So log 3 of the add puts it together with multiplication. Now I'm going to rearrange that to be exponential. So 3 to the 2 equals this result. So that's switching forms. And now this is 9. And then I'm going to FOIL. Now I'm going to zero this out. So minus 24. When I factor or try to factor, I think what multiplies to the 24, so 6 times 4, so x equals 6 or negative 4. If I plug them in, do they stay positive? 6 plus 3 positive, 6 minus 5 positive, negative 4 plus 3, nope, not positive. So 6 is the answer. Okay, number 15, I'm going to collect. So log of x squared plus 5 divided by, and then equals log, and then 3. Since those logs are the same, remember this is a base of 10, those are the same, I cancel them out. So now I'm going to cross multiply. So x squared plus 5 equals 3x squared plus 3. And then collect, we'll go minus x squareds. Oops. 2x squared plus 3. Okay, so now I'm going to minus 3. And divide by 2, 1 equals x squared, so x equals 1, x equals negative 1. And let's check 1 squared plus 5, that stays positive, positive. And if you square the negative 1, it also will work. So they both will work. Okay, number 16. Now I'm going to collect. So log a of the collection, so that would become 3 squared, and add would become times 4. So log a of, so this is 9 times 4 is 36. Now I'm going to rewrite it, right, that's the base. So a squared equals 36. So a could technically be 6 or negative 6, but it says that a is positive because we do work with positive bases. So therefore a equals 6. solving algebraically again, so I can't do same bases, so I'm going to log both sides. So the rules, that's multiplied, so now it's going to add. So log 2 add, this will be in the front, so x log 7 equals, this will move into the front. Okay, so these two things are multiplied together, so they added. Now I'm going to distribute. So 2x log 3 minus 3 log 3. Collect anything with x's together, so why don't we move this way? At the same time, I'm going to be moving that way. X stuff one side, non-x stuff the other side. So log 2, I said I was going to stay and then moving that, so plus 3 log 3 equals 2x log 3, and then I said I was going to move that, so minus x log 7. So I'm going to take an x out, and then to get x alone, I'm going to divide by 2 log 3 minus log 7. Okay, so that's what I'm going to be typing into my calculator. This, and then remembering that it's going to look like that when I type it in. X equals 15.872. Okay, solve algebraically for number 18. So this is exponents. So I'm going to write it in log. I'm going to log both sides. Okay, so when I do that, this will move to the front. Okay, now I'm going to times both sides by 2, just to get rid of that. So x log 7 equals 2 log 85. To get x alone, I'm going to divide. So this is what I'm typing into my calculator, and it's 4.566. Okay, so this one I'm going to try to group all that together. So log of, there's an x, the plus multiplies, the subtract divides. Now I'm going to forget about those two logs because that's set to be the same. So this is 4x over x minus 2. Equals 5. And now I'm going to times both sides by x minus 2. So 4x equals 5x minus 10. I'm going to subtract 5x and divide. So x equals 10. Does that work? Plug it in there. Result is positive. Result is positive. Okay, on this one, you can do the log of both sides, or you can do the natural log of both sides. Sometimes when I see an e, then I do that, because there is a step where it will cancel out, making your math easier here. So the rule, this exponent will go in front, exponent will go in front. So here's why it will help, because the ln of e is just 1. So I can just say it's crossed off, because if I times that by 1, Okay, and you can, if you did the log, you're gonna have to FOIL that out and everything, and that's fine too. X ln 7 plus 1 ln of 7. I'm going to move x stuff to one direction, so that's going that way. And then I'm going to move that to that side because it's not an x. And then I'm going to take the x out to get x alone. I'm dividing. So this is what I'm typing into my calculator. So your final answer should be 91.439 when you type it. Number 21, somebody was trying to solve this, and then they did that equal to that, which makes sense because both log 7, and then they did add 2 to both sides, and then they subtracted 1, and then they got 1 equals x, and then they did that. Why is that not working? Why did they cross it off? So if I plug it in, 1 subtract 1 is 0. That is not a positive result. And actually when I plug it in there, 2 times 1 minus 2 is also 0. So your results always have to be positive. Okay, number 22. Solve algebraically. So I think I'm going to take this form, log form, and change it to exponential form. So 2 base, right? Base result exponent. 2 squared equals log 3x. So 4 equals log 3x. So now I'm going to change this again to exponential form. So now this is the base result exponent. So 3 to the 4 equals x, which is 81. Okay, and then this one. So on this one, I'm going to move the logs to one side together to do some collection. So log 2 of that plus log 2 of that. So now I can collect, because they're on the same side here. So log 2 of, since this is add, those would get multiplied. So now this is base results exponent. I'm going to move that around. So 2 to the 5th equals this. So 2 to the 5th is 32. And I'm going to FOIL. I'm going to zero this out. So minus 32 is minus 35, and then factoring, I get a 7 times 5, so x equals -7, x equals 5. Let's check. If x was -7, that makes a negative, so that one's gone. If x is 5, positive, positive. So that one would work.